We know that like charges repel and unlike charges attract. So always charges create their own field around them and they attract and repel the different kinds of charges. With what force? What's the amount of force? And that is given by Coulomb's inverse square law. And Coulomb gave a law saying what are the factors which decide the force between 2-point charges. What do you mean by a point charge? A point charge is one whose size is very small. Its charge may be anything, but its size is very small. Now let me take two positive charges, Q1 and another one is Q2. Remember, Q is the symbol used to denote charges. So they are the different charges. Let they be separated by a distance r. Let this be r. Now what is the amount of force between them? Now as you know, Q1 repels Q2. So Q1 exerts a force on Q2 and because of which Q2 will start moving to this side. Imagine that Q2 is in your hands and you are standing here. When you are holding Q2 and standing here, you feel a repulsive force given by Q1 on Q2. So that force experienced by Q2 and given by Q1 is force on 2 due to 1 is in this direction. So Q2 is repelled in this direction. What Q2 will do? This is simply in accordance with the Newton's third law. For every action there should be an equal and opposite reaction. So on the contrary, Q2 will repel Q1 in this direction. So Q1 will experience a force which is given by Q2. So force on Q1 due to Q2 will be in this direction. So these two forces are in opposite direction. So action and reaction are equal and they are in opposite directions. So if you want to write the formula for this, Coulomb's inverse square law helps you. And Coulomb's inverse square law says that force between any two charges, point charges, placed at a point or at rest is directly proportional to, so force between the 2-point charges, these two charges, I will write the general formula, F, should be directly proportional to the product of the magnitude of the charges. Definitely the force between these two should depend on the amount of charges. Suppose you replace Q1 and Q2 by a stronger charges, definitely force will be more. So it is directly proportional to product of the magnitude of the charges, the amount of charges. And if these two charges are placed away, definitely the force between them will be less. So it is inversely proportional to square of the distance. Hope you will be remembering Newton's law of gravitation, where the gravitational force is directly proportional to the product of the masses and inversely proportional to the square of the distance. More the distance apart the objects are, lesser will be the force. So force decreases as the square of the distance that comes in the denominator. So this is the Coulomb's inverse square law, and it can be stated like this: the electrostatic force between 2-point charges at rest is inversely proportional to the square of the distance between the charges and directly proportional to the product of the magnitude of the charges. And now, is there any other factor which decides the force between these two charges? Yes, there is. The medium between these two charges. Suppose you change the medium from air to any other medium, then the force will change. According to the medium, we will get the force. So, which factor will be introduced here? So, we will introduce a proportionality constant, and suppose you don't change the medium, of course, that constant will decide what is the medium. And F, if you want to write equal to the constant of proportionality, Q1, magnitude of Q1, magnitude of Q2, and inversely proportional to square of the distance. And this K is nothing but 1 by 4 pi epsilon naught. Remember, this constant is called epsilon naught. I will tell you what is epsilon naught. And so if you introduce this here, this is the value of K, then F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared. So this is the mathematical form of Coulomb's inverse square law. The force between 2-point charges at rest, and they are kept in air, remember. So at rest, that force is inversely proportional to square of the distance between the charges and directly proportional to the product of the magnitude of the charges. Okay. Now what is epsilon naught? We will see that. Epsilon naught, if these charges are kept in air, then epsilon naught is called permittivity of the free space or air or vacuum. Permittivity of, I'll write vacuum now, or even you can write air. So epsilon naught is called permittivity of vacuum. What do you mean by permittivity? Permittivity is the value which gives you how strong will be the force between these two charges when they are kept in air. More the permittivity of the medium, lesser will be the force, because permittivity comes in the denominator. So this is the formula. And suppose you want to write this Coulomb's inverse square law in the vector form, then F is equal to 1 by 4 pi epsilon naught, magnitude of q1, magnitude of q2, inversely proportional to square of the distance, and I'll join one more unit vector r cap. And you have to explain what is r cap. R cap is a unit vector in the direction of force.